All right, good afternoon. Today we are talking with Dr. Agbas. Dr. Agbas is a professor in the Basic Science Department on the Kansas City campus here at KCU. Dr. Agbas got his doctoral degree at the University of Szeged, Hungary. Following that, he did some postdoctoral training at both UMKC as well as KU Med in the Kansas City area. He then went to KU Lawrence and he spent 13 years there. He served as a research assistant professor and he came to KCU in 2010 and he's been here ever since. So welcome, Dr. Agbas.
Thank you.
So just to kind of get us started, why don't you give us a 30-second elevator pitch of your current research focus?
Well, thank you. Yeah, it's a fine art to talk about the 30-second elevator pitch. I'll try my best. My overarching research interest is the molecular biology of aging and aging-relevant diseases such as Alzheimer's disease and non-aging relevant neurodegenerative diseases such as ALS, ankylosing body myositis, IBM, and musculoskeletal disease in general. These diseases are in rise. No cure is available, and early diagnosis is essential. My research team, named Team Q, is currently working on developing and validating blood-based biomarkers for Alzheimer's and ALS. We also have a mitochondrial relevant studies, as you can see, my patches here. Mitochondrial respiration as a biomarker. So looking at the behavior of the mitochondria, whether this mitochondrial respiration profile will tell us something about the early diagnosis. That's pretty much it.
Okay. Well, that sounds very interesting. Why don't you now tell us, in your opinion, what makes your research important? What makes it stand out? And what are some of the possible applications for future physicians or physicians in general that can grasp from your research?
Yeah, we as Team Q are currently working on developing blood-based biomarkers for neurodegenerative diseases. Currently, our focus is on AD and ALS. A robust peripheral biomarker is not available for neurodegenerative diseases for making early diagnosis and following the prognosis of those diseases. With a validated blood-based biomarkers, physicians will not miss the window of early treatment opportunity and also monitor the prognosis of the disease. We are expecting that our research will contribute for developing pharmaceuticals that can be used in a timely manner.
Okay, so I have a question about the mitochondrial biomarkers that you mentioned, the respiration. Um, how is that something that you measure? Is that measured at a cellular level, or are you thinking that can be measured in the blood?
Yeah, what we do, we just took the opportunity of the blood cells that has the mitochondria, especially platelet. Platelet is like a mitochondria bag.
Mm,
So we isolate the platelets without the damaging of course. And then we have a system, what's called the extra flux analyzer, or also known the seahorse analyzer. So we seed them, and there are certain drugs that inhibits the electron transport cascade, and everything is just automated. So at the end, you got the extracellular acidification rate, basically pH changes, and then OCAR, oxygen consumption rate, so how much the cells are respirating. So a lot of the software behind the curtain involved, and then at the end we got the some sort of the graph, and then we learn how to analyze the graph, and then we see whether the mitochondria is respirating well, or mitochondria electron transport cascade is working well. With this one, you can really monitor uh, how the treatments are effective, and then what is the prognosis of the disease. It's really cool.
Yeah, it sounds really cool. So when you look at the respiration rate or the efficiency, are you looking at things like superoxide production
No.
or?
Well, I mean, there are, at this moment, we are not looking at the superoxide enzyme activity. Superoxide enzyme activity can be done without that sophisticated instrument.
Okay.
Basically, we are looking at the pH changes and an
Hmm.
oxygen consumption.
Okay.
And it's a
Okay.
fact that we can analyze the ATP rate too, ATP production rate indirectly. Yeah.
Oh, wow. Wow.
Yeah.
That sounds really neat but complicated.
Well, actually, it's really cool that once you get this one, and then you really, it's like a video game. You don't want to leave this, the
Yeah.
instrument. Yeah,
Great. So, I know you work with students all the time,
yeah,
in from both the Cobb as well as the COM.
yeah,
How do you feel that working in your lab helps prepare medical students for a career in medicine?
yeah. Well, as you have mentioned, Dr. Kimmer, our lab is not only providing an opportunity to get involved in research for both COB and non-COM students to plan, execute experiments and essays, and interpret the data, but also a fertile, active learning environment. I often appear in the lab. Sometimes I work on my bench. And yes, I'm still active. I'm still active in my bench. And we meet weekly in Zoom base and discuss about the findings, solve the problems, and learn from one another. I encourage my students to apply fellowships, and then both the internal and the external. So they providing an environment, then they can extend their studies, what they learned in the classroom, and they put into practice in the lab.
Okay. So maybe just expand on that a little bit. And why do you feel research in general is important in a good medical school education?
Well, research provides an environment where students enhance their learning by doing it. So that's really essential. Honing their analytical and critical thinking skills and teamwork. Because in the lab, we are working with the very small groups, and then they are really interacting. And then also analytical, because I pose the questions. Why do you think that you got this result? Why did you get this image? How did you run the experiment? Why did you follow this way? So really encouraging the students to put what they are thinking into the words. That's really important because it hones their communication skills. And then these are very essential for medical school education because they are going to be a physician. They are going to work with the nurse, healthcare workers, and then others. If they are learning very early stage in their medical education, how to work as a team player and on how to think analytically and critically, I think it's a big plus, for them. Also, concept of being the physician scientist gain popularity among the medical students more and more, either the MD, PhD, or DO, PhD. As a matter of fact, that our school had a mission, hopefully, that institute the DO, PhD program. I don't know when, but there are talks. Yeah,
Great. Yeah, what you say about science communication, I'll double down on that with you. I think we've seen that, with this pandemic, the COVID-19 pandemic, that communication from not only physicians, but scientist physicians is crucial. So many people believe and want to believe what their doctors or their physicians are telling them, and it's critical that our future physicians learn how to communicate scientifically, in a way that the general community can understand. So, I think it's great that you're providing the opportunity for our students to experience that and really start honing those skills.
Yeah, absolutely. I mean, we are using a lot of, the lab jargon in the lab, but when it comes to communicating with the others, they should be able to really skim down and then deliver the message without losing its essence.
Correct. Yeah. Okay. So, how many students or residents or fellows do you think or know that you've worked with or trained in the past? And what are some things that they've gone on to do after training with you?
Yeah. Before KCU time, I used to work as a bench scientist. So I had a few students and postdoctoral fellows that I trained. However, uh, at KCU, the number logarithmically increased. During the 11 years of my tenure at KCU, our lab had provided research opportunities for 54 students from
Wow.
both COM and NCOP. 8 COM students had received SSRF fellowship, Summer Research Fellowship, and 1 student had received American Osteopathic Association SOMA fellowship. So
Mm,
she really competed in national and she got that one. And currently, our lab has 10 students from both COB and COM. And we have got one high schooler joining from Joplin too. I didn't
wow.
want to really turn him down. He's coming and then joining to our lab meeting, and I'm planning to give him some literature work that he can present. And we are applying for SSRF fellowship and AUS osteopathic medical student research grant with one of COM student this year.
Great. That sounds like you've had an impact on a lot of students.
I hope so. I hope so. Yeah. If I can make a little difference in their life, because my understanding is that this is the only opportunity for them doing the research. Some of them are coming from undergraduate education. They didn't have an opportunity. And then when they are going to the residency program, I don't know when they are going to end, but at least that one summer and 2 semesters, they have a kind of, the taste of the research, then
Hmm.
what this research means, the kind of research life. So it's a kind of little impact if I can make, then I think that I achieved my goal.
Great. What what is probably the biggest piece of advice or one piece of advice that you would give to current medical students? And it can be about anything, whether it's about research or whatever.
Okay, a few of them, they keep calm and carry on learning new things. Science is infectious, so get infected in a positive term. Learning new knowledge, skills, and thinking are the way to keep you young, energetic, and always curious. Do not let your 2 days be equal. Otherwise, you will be unhappy and dissatisfied with your life. Always think positive and act positive. Do not get vortexed into negative energy field. These are my words of advice for students.
Those are good words, I think. I can resonate with several of those. Dr. Agbas, it's been great talking with you, and I really appreciate you taking the time to do this. You've obviously, like I mentioned before, had a big impact on a lot of students, and continue to do so here at KCU. And I know the KCU community appreciates everything that you do. And so we'll be in touch soon about your research and maybe get an update from you.
Sure. Thank you very much, Dr. Kramer, for giving me the opportunity to talk about my research to KCU community. I do appreciate it. Thank you.
All right. You have a good day.